In this video, we're going to look at topic 90, example 3, rewrite the product or quotient of a radical. So question A, what is the reduced radical form of each expression? We don't really need all of that, but yeah, part A, we have the fifth root of 16 times the fifth root of 8. Well, 16 is not a perfect root, 8 is not a perfect root, and they can't be broken up into perfect fifth roots. So what that tells me is that I should put these two together through multiplication, which I'm allowed to do because of the same index. So 16 times 8 is 128, which also is not a perfect fifth root. However, although I had two separate terms, 16 and 8, and put them together, I can pull this 128 back apart, but this time I'm going to use 32 times 4, because I know that 32 is a perfect fifth root. So the fifth root of 32 is 2, and then the fifth root of 4 would remain inside. Okay, so for problems like this, usually what you want to do is, if they can't be simplified individually, you're going to put them together and then take them apart in different pieces, which we showed here. We're going to skip example B for now, so don't worry about example B, and we're going to jump to example C, where we have the cube root of 2n over 9m. The first thing I should look for is if I can reduce my fraction. 2 over 9 cannot be reduced, and n over m cannot be reduced. So there's nothing I can do here. So what I'll do is I'm going to change this to the cube root of 2n over the cube root of 9m. Okay, so I'm just separating those, and you can see that up here in the quotient property of radicals. Now that they're separated, I need to rationalize the denominator. Okay, I can't have a radical in the denominator. And to do that, I need to create a perfect cube in the denominator. So my perfect cubes, right, I have the cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, and so on. So I need to turn my denominator, this piece, into one of these. And what I'm going to look for is, what number does 9 go into? Which perfect cube? Well, 9 does not go into 8, so I can't use this. 9 goes into 27 though. 9 goes into 27 3 times. So what we're going to do is we're going to multiply by the cube root, and we want to turn this into a 27. To do that, I need to multiply by 3. It'll take a little getting used to with that, but you're trying to turn these into perfect cubes, and you just need to have a list of the perfect cubes or perfect squares, whatever the case may be, and you need to turn that denominator into that number by multiplying by some term. I also need to do the same thing for the m. I need the m, basically the exponent, to be divisible by that 3 out there. So right now, I have an m to the first power. So if I need m to the cubed, I need to multiply by m squared, right? Because m times m squared is going to give me m cubed. And this is what I'm looking for, because that matches my index. Now, since we're multiplying, we're going to multiply by effectively 1. So whatever the denominator is, the numerator is going to be the same thing. The reason for that is this whole term is equal to 1, and by multiplying by 1, I'm not actually changing the value of anything. Next, you're going to multiply the numerator by the numerator, so you get the cube root of 6m squared n. Multiply your denominators, so that would give us 27m cubed. And now when you get here, this denominator should be a perfect cube. 27 is a perfect cube, m cubed is a perfect cube. So you'll simplify your denominator. Cube root of 27 would be 3. The cube root of m cubed is m. And this is what we're left with. All right, we cannot do anything with the 6m squared n, because there's no perfect cubes there. They can't be broken up in any perfect cubes, so we would stop here. It will take some getting used to. Part A is a little bit easier. Part C is a little bit more involved. There's some more thinking to do. But the idea is you're trying to turn the denominator into a perfect square or a perfect cube or a perfect fourth root, whatever example they give you. And to do that, you're going to have to multiply by some specific value to turn that into that perfect root. Practice those problems. You will get the hang of it. It will take a bit of practice, but you'll get there.